Alright, so hopefully you've already copied these power reducing formulas into your notes. If not, pause and then move on when you're done. So the power reducing formulas, I'm not going to say they're used a ton, but they are used when a sine or cosine is raised to a power. So here the goal is to write sine to the fourth as using only sine and cosine raised to the first. You can do anything else, but essentially no exponents. So first off, I think of sine to the fourth as sine squared x all squared. And now we can actually use our first application of the substitution. Sine squared x is equal to 1 minus cosine 2x over 2. Right? So this is what's in your notes. 1 minus cosine 2x. That's what's in your notes. I think you had it probably with a u instead of an x, but that's what we're using here. So I'm taking this whole big set of parentheses and replacing it with 1 minus cosine 2x all over 2, but it's still raised to the second because this part I cannot change. I can't substitute out two of them. All right, from here, this is, some people would like to think of this as, you can think of it as two fractions, but it is still a binomial squared. So I'm actually going to square that, right? So I'm going to think of that as a binomial times a binomial. So at this point, I need to do a little bit of a FOIL. What's happening here is I'm going to do the 1/2 times the 1/2. That's going to be 1/4, 1/4, and then I'm going to have minus. That's going to be cosine 2x over 2, another minus cosine 2x over 2, and then I'm going to have plus cosine squared 2x. I'm sorry, both of these are over 4. It's my mistake. So I'm going to do two steps at once. I'm going to combine these like terms in the center, but I'm also going to factor out. All of these terms are a fraction. They all have 4 in the denominator. So I'm going to factor out the 1/4. That means essentially all of these are gone, and now I'm just combining like terms with what remains. 1 minus 2 cosine 2x plus cosine squared 2x. All right, so here's the last tricky part to this is I cannot leave this answer the way it is because there is this squared here, and remember in the directions we said no exponents, everything needs to be raised to the first power. So I have to use my power reducing formula for cosine, and if you remember the power reducing formula for cosine squared x is going to be 1 plus cosine 2x. Now, the tricky part here is I've got this 2 right here, and it's a little different. Now, notice the difference. This doesn't have a 2 right here. But if it does have a 2 right here, I would have another 2 in this space. So it would be 2 times 2, which is why when I replace this, I'm going to be writing plus, and here's my fraction. I know the bottom's 2. I've got the 1 plus. The tricky part to this formula it's not 2x, it's 4x because of this 2 right here. And we could simplify just a hair, and what I mean by that is I could put this over 2 and this over 2, only because it gives me a few like terms, and we could say 1/4 parentheses, that's going to be 1 plus a half, that would be 3 halves minus 2 cosine 2x. Plus cosine 4x over 2. One little parenthesis there to make it completely correct. Now, this is a completely correct answer, although some people would argue that if you distribute everything, that would be a correct answer as well. Several different ways to write your answer here. But I'm fine with what's on the board. Like I said, you don't see the power reducing formula that often. You do see half angle formulas. They are very similar to the double angle formulas in the fact that we use, and I'll show you some examples here. The tricky part to half angle formulas is this. We'll take a second, pause the video, copy these into your notes. And what I'm going to say, the tricky part to these half angle formulas is these plus or minuses. And the half angle formula doesn't determine signs in terms sign plus positive or negative. What half angle formulas do, it gives you really the absolute value, and you have to think about, well, depending on what quadrant u over 2 is in, that's going to determine your sign. Like, you know, if cosine is in quadrant 2, the answer has to be negative. So if u over 2 is in quadrant 2, and you're using the half angle formula, well, your answer better be negative. So you have to take that into account. If you're working in quadrant 1, everything's positive. If you're working in quadrant 3, sine and cosine are both negative. So those are ideas that you need to take into account as you do this. You don't need to do it with tangent. Tangent works as is, so you don't even worry about positive or negative. It's always a nice way to check your answers, make sure your signs are right. But moving on. Okay, so we've actually done this problem before. We used the sine of a sum, right? We wrote this as something like 45 plus 60 degrees, right? And those were both values on the unit circle. Well, that's one method you could do for this problem. What we're going to do is show it a second way. And the second method is using the half angle formula. I notice 105 is 210 over 2, and 210 degrees is on our unit circle. It's in quadrant 3. Again, 105 would be in quadrant 2. So I'm using that sine of u over 2 is equal to plus or minus the square root 1 minus cosine u over 2. Right, so that's the formula I'm using. The way I'm going to rewrite this sine 105, because 105 isn't on the unit circle, I'm going to instead think of it as 210 over 2. And then I can use this half angle formula, do the square root of 1 minus the cosine of 210 over 2. Now, I do know the cosine of 210. The cosine of 210 degrees is negative radical 3 over 2. So this would read out square root 1 minus negative radical 3 over 2 divided by 2. And then it's a matter of canceling. So right now it's a complex fraction, and I would need to simplify it a little bit. I do know that my answer, I do know my answer is positive, because in quadrant 2, sine's always positive. So to get rid of this fraction right here, what I'm going to do is I'm going to multiply by 2 over 2. And what that does is on the top it does a little distributive property. I multiply the 2 to the 1, that's where I'm going to get a 2. This 2 would cancel out, and the whole bottom is going to be 4. So let's see what happens here. I'm going to have 2 minus, plus, because of subtracting a negative, make that a plus. We're going to have radical 3, all divided by 4. And I could even go one step a little bit further. I know the square root of the bottom. 2 plus radical 3, all divided by 2. And I'm perfectly okay with a radical inside a radical here. That is accepted as an answer. That would be our final answer here. Okay, so here's an application of the solving for x that we've done pretty recently. And what we're going to need to do is we're going to need to do the half angle formula here. The half angle formula that I'm going to be using in this problem, cosine of u over 2 is equal to plus or minus the square root of 1 plus cosine u over 2. That's the formula we're using, and we're going to be substituting out this piece right here. Now notice, this piece is squared, so when I go to rewrite this, I'm going to have to take that into account. Minus sine squared u equals, this 2 has gotten copied over. Now it is the square root of 1 minus cosine u over 2. And then I have to copy this squared piece over. And it's actually convenient that that squared is there, because the squared and the square root are going to cancel out. So I can essentially ignore this and ignore this because they've canceled out. And because I'm squaring what could potentially be a positive or negative, when I square a positive or negative, I'm always going to get a positive. So I can, that squared makes this much easier to work with. So 2 minus sine squared x equals, this is 2 parentheses 1 minus cosine u over 2. Go one step further, the 2's cancel out. And now it's solved for x. And we can, using the strategies we've seen from the last couple sections, sine squared is equal to 1 minus cosine squared. So 2 minus, parentheses, 1 minus cosine squared equals 1 minus cosine u. So now I would distribute this negative, make this add opposite opposite. So I would be looking at 2 minus 1, and as I get everything to one side, minus 1, minus 1, all three of those add to one big 0. I'm going to cancel them all out. In fact, those cancel as well. If I move the cosine u to the other side, I'm sorry, cosine x, I'm writing the wrong variable there. As I move the cosine x to the other side, I'm left with cosine squared x plus cosine x equals 0. From here, our only option is to factor and solve. You've got a common factor there. And you're going to create two equations. Where is cosine equal to 0? Where is cosine x plus 1 equal to 0? Better known as where is cosine x equal to negative 1? Well, cosine is equal to 0 at pi over 2 and 3 pi over 2. And cosine is equal to negative 1 at x equals pi. And notice I did not need to add the plus or minus, or the plus 2 pi k because of my directions. This section is, we have one more piece. There's going to be one small video that these last few formulas are actually the easiest of the day. So if you could copy these in your notes, in the very short next video, you will see how you use these.